Welcome to today's lecture. Myself Dr. Tukur Gupta from EC department. The subject that I am covering in my lecture series is Fundamentals of Electronics Engineering. Today, the lecture I will cover is on the topic Boolean expression minimization using K-maps, that is Karnaugh maps. Let's begin with the lecture. The contents for today's lecture consists of the methods of minimizing Boolean expressions, a small discussion on this issue, then the rule of minimization using K-maps, because using K-maps is a very complex topic as well as a very critical and important topic. So, we will discuss few rules before starting with the numericals. Then we will come to the numericals, that is the problems based on K-maps. So, let us understand that there are two ways to minimize any Boolean expression. First of all, a very simple yet that is, you have to remember the rules. So, for some it is quite complex, and for some people it may be bit easy to remember. So, first of all, the first rule is by using the laws of Boolean algebra. That is a bit complex issue, because you have to remember the rules, you have to remember the laws. And a second way to minimize the complex numericals, we use the K-maps. So, that is also known as the Karnaugh maps. Let us see. So, in today's lecture I will cover only K-maps. So, let us see what are the K-maps. Karnaugh map is called the K-map, and it is a graphical representation that provides a systematic method for simplifying the Boolean expression, because we are using a graphical method. So, it seems easy for many of us. So, for a Boolean expression consisting of n variables, suppose you are having n variable system, n variable expression, and you need to minimize it. So, how many cells a K-map will have? It will have 2 raised to power n cells. So, suppose there are x, y and z. These are the 3 variables in the system. So, you will use, your K-map will use 2 raised to power 3, that is 8 cells. So, how will the K-map, for example, I am just giving a small discussion, how will it look like? So, in this way your K-map will look like, because you are having 3 variables and the number of cells should be 2 raised to power 3, that is 8. So, it is having 8 cells. In this way, with a higher number of variables, you will be using the K-map with a more number of cells. So, in our syllabus we are having the K-maps for how many variables? For up to 6 variables. So, let us see. So, there are certain rules which you have to follow before going into the details of K-map, before using the K-map for your Boolean expression minimization. So, what does the rule 1 say? Rule 1 says that we can either group zeros with zeros or ones with ones, but we cannot group zeros and ones together. So, what are these ones and zeros? Before discussing this lecture, I am assuming that you all of you know about the min terms and max terms. So, where there are the min terms, so that is representing ones and otherwise zeros. X representing don't care can be grouped into zeros as well as ones. There is no need of separately grouping X, that is, they can be ignored if all zeros and ones are already grouped. Okay. So, if you are left only X, that is a don't cares, you need not group them. Now, group 2, that is rule 2, that groups may overlap each other. So, during the minimization using K-maps, you can overlap the groups. Suppose the elements in a particular group have been used, you can use those elements as well to make another group, that is known as overlapping. What is the rule 3? That you can create a group whose number of cells can be represented in power of 2. By saying so, what it means that you can make a group of 2, you can make a group of 4, you can make a group of 8 and so on. So, group of 2 is a pair, okay. Then group of 4 is a quad, and group of 8 is octet. Okay, so you can also group 2 octets. So in this way you can make the groups in the power of 2, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3 and so on. So, and now according to rule 4, groups can only either horizontal or vertical. You cannot create groups of diagonal or any other shape. So what does that mean, that group can be this way, like these are the elements, group can be this way, otherwise group can be this way, group cannot be this way. This is wrong. Diagonal grouping is not allowed in K-map simplification. Rule 5 says that each group should be as large as possible. So you have to make group as large as possible. If there is a probability, if there is, you can look at the possibility that group of 8, that is a octet, can be formed. So don't go for quads or for pairs. This is a very important rule. Always look for the larger groups in your K-map. Group 6, opposite grouping and corner grouping are allowed. Like suppose this is your group, this is your K-map. Okay, so you can go for this group, you can go for this group. These are the opposite groupings, and you can also go for this group. This is the corner grouping. So these are the opposite groupings, these two, and this is the corner grouping. So in this way you can make groups. These are allowed. Rule 7 says that there should be as few groups as possible. When you should look for the larger groups, and when you will make the larger groups, obviously you will land into the fewer groups, you will land into the lesser number of groups. So you have to keep a check on this, that there should be as few groups as possible. Number of groups should be very less. Now let's come to the problem. First problem is this: we can identify that there are 4 variables. So when there are 4 variables, your K-map will contain 16 cells. So let's solve this. So how will you number K-map? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. This sigma m indicates that this is a type of sum of products form. Okay, so the expression, the final expression you will get will be in the sum of products form. Okay, and you will fill these places denoted by these numbers. So how this is the way of numbering any K-map. This is the 16 cell K-map: 12, 13, 14 and 15. So this is how you will number the K-map. Now when we are talking about the variables, this portion handles AB, this portion handles CD. This is for CD, this is for AB. So this is denoting 0, 0, 0, 1, 1, 1, 1, 0, again 0, 0, 0, 1, 1, 1, 1, 0. 0, 0 indicates A bar, B bar, A bar, B, A, B bar, A, B and A, B bar. Similarly, C bar, D bar, C bar, D, C, D and C, D bar. This is how you will write the variables over here. Now, you have to fill these places in your K-map with 1. So 0 is there, 1, then 1 is there, 2 is there, then 5 is there, 7 is there, 8, 9, 10 is there, then 13 and then 15. So how will you make the groups? You have to look that what are those places which have no other option but to make the group themselves. There is a necessity to make the group. So you will find that these 4 corners have to be together. Anyhow, this is the best option by which these 4 corners can be grouped. So this is making 1, quad. Okay, so this is quad 1. Now another, we can see that these 4 can be together. Okay, so this is quad 2. Okay, and another way is to, so basically there are 3 ways. This is quad 1, this was quad 2, and this is quad 3. So I have provided a hint over here. So yes, this is, we have solved it correctly. So there are 3 quads which we can recognize, which we can form, and now we will now make the final expressions. So let us first consider this blue quad, that is a quad 1. Let's see how the expressions will be formed using this quad. So finally, you can see these two are together, like 4 of them are together. So when we are having a look at AB, so A bar, B bar and A, B bar, from these two we have to find the common. What is the common? B bar is common. So here B bar is common from these two. Okay, so A plus A bar, this will make 1. Now plus from the CD row, we will see that D bar is common. So D bar is common and C bar plus C. Okay, so while forming this quad, we can see that you have to consider A bar B bar plus A B bar and C bar D bar plus C D bar. So from here, from A bar B bar and A B bar is common. This will give you 1. And from C bar D bar and C D bar is common. This will give you 1 again. So what is the final expression for this? Final expression is this. So final expression looks like B bar B bar D bar. So in this way, this is expression for this quad. Now we will consider quad 2. For quad 2, the expression looks like these all are cancelled together. Only left is C bar D bar, C bar D bar. So for this it was B bar D bar. For this, for this quad 2, it was C bar D, because C bar D only exists. All of are cancelled by taking common. And the last one is this red quad. For the red quad, the common is B. For this B from here, A bar and A is making 1, B from here and D from here. So the final expression is B bar D bar plus C, okay, B bar D bar plus C bar D plus BD. So this is the final expression. So in this way we solve the K-map. So this was the first K-map that we have solved. So it becomes quite complex. Let's see the another one. So this is the final expression we can see. Now let's see the another one. So similarly, there are 4 variables. Again, Now let's fill it. 0, 1, 3, 5, 7, 8, 9, now 11, 13 and 15. So there are, obviously we can see this whole octet is there. Yes, so this is your octet. Yes, and another option is these two have to be grouped together, these four. Okay, so this is making quad. So here we can see that we are overlapping the groups. The elements that are already used in this octet are being overlapped. But yes, this is the best option to make quad over here. Okay, you could have gone for this group also, only this group, but this is not a good option, because you have to always look for the larger groups, as I told earlier. So the largest group is this octet, and then the next option is this quad. So there is a one quad and one octet. So what will be the expression for this octet? The expression for this octet will be, these all four have been cancelled. The only option is C bar, D bar and CD. So what is common in C bar, D bar and CD? This D is common. So we are left with D. Now for this quad, the expression for the quad is, we have to consider A bar, B bar and A, B bar. So the common is B bar, and from this C bar, D bar and C bar, D, the common is C bar. So the final expression is F equal to B bar, C bar plus D. So this is the simplified expression for this Boolean function. Now let's discuss a problem with the don't care. This denotes don't care. What is don't care condition? That these variables, the positions, these can be used to minimize the expression. And it is not necessary to use them, but if you see that using these don't care variables, you are able to make a larger group. Obviously, you should go with them. You should use them. Let's see how. Again, this is a 4 variable K map. So we will fill it with the ones 1, 3, 4, 6, 8, 9, 11, then 13, 15. And the don't care is 0, and then 2, and then 14. So now we will make groups. So first group which we can see is, here I have provided the hint. So first group you can go for is this one. Yes. Another group you can go for is this. So here it is better to use the don't cares, because why to use the don't cares? Because using the don't cares you are able to make a larger group. Otherwise, if you are not considering these two don't care, at the 0th position and the second cell, so you will land up with the making of only a pair, but that is not a good option. So you should always try to make a larger group. So you will use these don't care conditions. Another group another group you can see that these two are left. Which two? these two. So how will you make the groups? So again we are going for the overlapping, but we are learning into making a larger group. Another option, we are left with this. So how will we make the group using this? Otherwise there was no other option to include this element. So we are ending with the making of 4 quads. Okay, so this is the first quad is this. Let's see, this is first quad. So using this, what will be the expression? A, and from here D. Yes, here the A is common and here the D is common. Now let's see another group, this using the don't care conditions. What will be the expression, final expression? Here A bar is common, and from these two positions D bar is common. Yes, again another group, this blue one. So using this blue one, P bar and D is common. Yes, we can see in the blue bar, circled expression, A bar is that is a B bar is common from this, and from these two D is common. So I have written B bar D. Another, we are left with a green circled group. So we will go for here B bar is common and here C bar is common. So the final expression is AD plus A bar D bar plus B bar D plus B bar C bar. In this way we can solve any of the K-map. So this is another a very simple K-map. Here we can see there are only 3 variables. So we will make a K-map using only 8 cells. So here A bar A, and this is B bar C bar, B bar C, B C and B C bar. So 0, 1, 2, 3, 4, 5, 6 and 7. This is the way how you will number these cells. So here the 0, 1, 6 and 7 and 3 and 5. This is the don't care. So how will you group them? So you can see that there is the way to group this. Okay, let me use another pen. This is the way to group these two, but eventually you will have to use these also, one group and two group. Now you will see that you, apart from these two groups, you are left with only these don't cares. So you are unnecessarily using these overlapped elements. So instead of you making this middle quad, if you go only for these two pairs, because it is very necessary to make these two pairs, otherwise you will not be using all the elements. You are not grouping all the elements. So you have to eventually make these two groups. So this is unnecessary to include these two don't care conditions. Otherwise you will be making another extra group, and this is not the rule. This is against the rules, because according to one rules you have to make fewer number of groups. So your problem is already solved by making these two pairs. So unnecessarily you need not use these two elements, these two don't cares. Okay, so in this way you can solve this K-map. Again, this is another problem, and this is again the 4 variable problem. So you will make a K-map using 16 cells in this way. Again, you can see that you could have made this quad, but eventually you have to make these 4 pairs, one second pair, third pair and fourth pair. So if you will be making quad as well, you are adding redundancy in your system. You are making unnecessarily another group, extra group. So that is not the rule. So again you will make only 4 pairs instead of making this middle quad. So this is another problem using the product of sums. This symbol indicates that this symbol was indicating sum of products terms, and this symbol is indicating this symbol is indicating product of sum of products, and this symbol is indicating product of sum forms. So how will you number this? Again the process is same, only the way of writing the variables, way of interpreting the variables is different. So this column is for AB, this is for CD. Again you will A plus B, A plus B bar, A bar plus B bar, A plus A bar plus B. So what is the difference? That here 0 0 is indicating no bar. So here 0 0 is indicating A plus B. 0 1 is indicating A plus B bar. That is the opposite. The process is opposite to that of the previous examples. So again 1 1 is indicating A plus B, A bar plus B bar, and 1 0 is indicating A plus A bar plus B. Similarly for this C plus D, C plus D bar, C bar plus D bar, and C bar plus D. Filling is same, okay, and instead of filling with these cells with 1, you have to fill these cells with 0. This is the rule. So you will fill wherever these at these positions you will fill zeros, and ultimately at the last when you will make the final expression, okay, grouping is similar, you will make the group similarly according to the same rules that you were using in the sum of products forms. But in this, at the end when you will make the final expressions, it will be in the product of sum form rather than in the sum of products. This is the only difference in this problem and the previous ones. So today we discussed how to minimize expressions using K-maps. So we have solved few examples with the sum of products, and a single example is there with the product of sum form. So I hope everything is clear, and and the more you practice these questions, because the toughest part of solving this expression using K-map is how you group. The students often make mistakes while grouping because they forget the rules. So you have to always remember the rules, and that's it. You will come up with the solved expression. You will come up with the simplified expression. So that's all for today. Thank you.